Hello, everybody. Welcome to our webinar 3 of the new feature offered by Automation Studio E7.0. I'm George Fatal, and today me and my colleague Christian Proto will be very happy to continue demonstrating to you how to use 3D virtual system in the new version of 7 of Automation Studio. By the way, for all of you having the software maintenance contract, you should have downloaded by now version 7.0 of Automation Studio. I will start my presentation and you can ask your question as we go in the question pan. Christian is here to answer them as soon as they are raised. And also, if there is other, if I answer them myself, I'll have the opportunity to answer on to your question too. So, okay. So, hi everybody. So today we'll be discussing the 3D virtual system in Automation Studio. The 3D virtual system in Automation Studio is a new feature that you'll be able to download using through the Automation Studio forum. So for all of you, if you try to join the internet on our website, Famic Tech, you know that if you reach the website, if you select support and forum, support, and select the forum, well, something I'm trying here to, yeah, here is the forum. If you select Automation Studio, the Educational Edition, you will have here, it's not ready yet, but you will have it over here as 3D virtual system. Probably going to get it on the file sharing section. And then you'll be able to get 3D virtual system. You got here the virtual system 2D and 3D. So if you go there, you'll be able to have the 3D virtual system that you can download to your station. Now, once you download the file will normally comes into in the download section on the file manager. You'll see it here. For example, I'm going to show you today the Drilling Factory 3D system. So once you download it, it's a zip file. What you're going to do, you're going to copy it, and then I dedicated for this presentation on my desktop a folder called Webinar 3D Virtual System. So I'm going to paste it. And then in the pasting here, what you'll do, like you can extract it all. So if I'm going to extract the file, so it will extract, and then you'll go there and then you'll find a setup.exe program, which you're gonna launch. If you launch, okay, so here I'm gonna say run away anyway and installing it. So this is the installation program of the 3D virtual system. So we'll select English and then next. Then you accept the terms, next. And then what it will do, it will do the installation of the file. Finish. Now what's going to happen, the installation of the file, once this thing is installed, the installation process take care of installing the file at the right section. So you normally, to show you where the file are located after the installation, they are located on the drive C. There is program data. Then you'll find a section called Famic Technology. And then you're going to find there the 3D systems. 3D systems, you'll see the Drilling Factory I just installed is over there. And here, once you go there, you'll be capable of, let's say, you can open and view it here, but I'm going to show you the viewer internally in Automation Studio. But here, it's a way of viewing the content of the file of what it's going to look like. So basically, this is a preview of the system. So you see here, this is the Drilling Factory that we're going to be using in our presentation. It's not ready yet to be, this is not how I invoke it, but this is just to show you how to view it. So here. So you're going to see it. So the system installed in Program Data FAMIC Technology 3D System Apps Drilling Factory. And also you'll find another folder which named 3D Demo Files. And here you're going to have a folder called Demos. And in the demos, you have demos of the drilling factory installed for you to explore and see once this system is installed, or these show you several examples that use this 3D system. And here is this is a solution using a PLC program. This is the solution of the drilling factory using relay logic, and here is SFC structured functional call. So here, so let's start, and then also before moving from there, you got here another section called the templates. And in the templates, you see the templates of the file to use, which is a blank project where it's already set for you to start using the Drilling Factory 3D system. By the way, the other file that you see over here that are a 3D system for other 3D virtual system I installed on my system here. So now I installed the Drilling Factory. The Drilling Factory is there, so I can close this window here and then move on to Automation Studio. So this is Automation Studio. This is where how you start the software. So from here, what you can do, you can start using the template. So I'm going to open the template created by the download. So here in the template, I'm going to go, like I said, in C, Program Data, and then FAMIC Technology, and then 3D Demo File, and then Templates, and then I'm going to select my template. So once the template loads, what you'll see over here is there is a new ribbon that got created, which is called 3D Link. And from there, you can invoke the system. Here is how to invoke it. And now the system, the 3D system, is ready for you to be used internally inside Automation Studio. So once you go over here, just to explore what it is, we have here a variables. If you click on variables, it shows you here the variables that we are available for in this system to be used in Automation Studio to do the animation, or let's say we'll show you here a PLC program that does some take care of moving this virtual system. So here, for example, I can force some movement. For example, if I want to extend the cylinder A, so I'm extending, you see here I extended the disk. What I can do here now, I can, let's say, turn my drill on. So the drill turns on. Now what I can do, I can just like extend cylinder C to drill a hole. So I can just do here and extend drill C, can retract it. So here, the movement, I'm doing them manually. And then after that, I can retract A. And then here it's up to me. I can stop the drill or keep it on, it doesn't matter. And then I'm gonna just like extend B to move on. So this is really a sequence I can do, then retract, and then go over again. You'll notice that this system is simulated. All the devices that in this system are available, that they are like you see over here. For example, we have a proximity sensor indicating that the cylinder is in, and you see here this is an indicator light, and you see over here the pop-up shows you the name of the variable that relates to this device. You see this one here is the block in place signal saying that this disk is in place. You got another one over here which tells you that the ready to drill, that's mean this disk has moved over here. When it's detected, it will turn it on, and then you see here the position for the B out, the position for the B in. The same thing over here, the cylinder here out and cylinder in, and then this is obviously, like the drill is on. You got the other signal that are not shown on the drawing that are displayed over here. And then what you notice also that we split this variable into two sections. One section to relates to the inputs and one section relate to the outputs. So for example, for all this section here, these are outputs because I can force them, I can act on them, so I can. And then this is the inputs that show me the status of the system. So you see over here, the cylinder A is in, it's on because it has a white color. Out is grayed, that means it's not activated. B in, you see B in, the signal here, and then C in, you see the signal, and then the block in place, and these are the remaining signals. Also, you see over here, we are providing each one of the 3D system for you a start button. And the start button, you see whenever I click on the start button, it sends me a signal on the start push button over here. Here, this is a stop push button. Now, this is a light here, the machine started. This is the indicator light over here. So if I turn it on, you see the light turn on. And I'm having also an emergency stop in case I need to simulate any stop situation in the system. So this is basically for it. Now, what else we provide here? We can, you see the system here, it's a 3D system, so we can switch cameras, and then we can have a free camera where, you can move on here, and or you can move on with your keyboard. You see here, if you hit on the keyboard, forward, backward, you do it with that forward, backward. You can do left, you can do right with the D, up and down, up and down with the E, for example. And then once, let's say I'm happy with the camera, a certain position, for example, I can do it like this. I can hit L on the keyboard, and then I locked my camera. I can lock the camera. So here I locked my camera to a position where and then I can save the camera. For example, if I do hit Control C, the camera is saved. Now, after this, I can switch cameras. So you see here, and then the saved camera, I can just click on this button. You can see the saved location. Then I can, let's say, if I end up in a situation where, let's say, the system is all messed up and then I want to reset the view here, I can reset the disk position with these things, and then I can even reset the scene where I return back to my default position of the 3D system. So this is basically the different things that you have in the system. Now let's work out with the system in Automation Studio. So to be able to work out with the system, you need to put the system in simulation mode. So once I turn it on in simulation mode, you see over here, it turned out, the light turned from red to green. That means that Automation Studio is now in communication with the 3D model. Now I can move on the model wherever I want. I can just use it as a split screen, or I can just turn it in a full screen. But let's say, for example, here I want to, let's put it back. I can close it if I wish. If I close it, cancel. I can open it again if I wish. So So let me put it in a format handy for me where I can work with. And what you see over here, it usually sits you can control also where you want to put it. Usually by default, we put it to be always on top of the project. But you can see here with the options, I can, if I do Unity here, Unity window always on top, I can just uncheck it, and then from there on, it's going to be like, if I check it now, and I put here, it will not sit on my top. In case I'm going to start using, let's say, if I do start the simulation, it will be put at the background. So now let me put it back again on the top here. Okay, we'll close the window for changes to take effect. Okay, so if I just do it, like if I turn it, uncheck it over here, and then close the window, and then start it again. So it's in there. So you see now it's sitting at the background, and in case I want to get it back, I have to come back to the taskbar over here, and then at the window section, I can bring it back to the top. So usually we like always to keep it on the top because we don't want to lose focus on it. So I'm going to change the setting back again to always on top. And then I'm going to close it and restart it again. It's, excuse me, my mouse is a little bit sticky. That's why it's not acting properly. So here it is. So now it stays on the top. Now, after that, after starting the system, I have to start it first at least once on the template. What you're gonna find out is that there is a variable that got created internally in Automation Studio here, and these are the variables that can be used to manipulate in Automation Studio to do all the animation of this of this system. So let's say if I'm going to put this window here a little bit on the side, let me put here and I'll show you a little bit what you can do if I'm forcing the variable. So you see over here, I'm going to be able to see the effect of manipulating this variable on the system here. I have to go and put it in simulation mode. Simulation mode is there. Now I have all these variables to play around with to do the animation of the 3D virtual system. So let me sort here first, and I'm going to sort my variable by name here. So for example, here, if I want to extend the cylinder, so if I do, I extend the cylinder, forcing the variable, so it will move the cylinder toward the front. Now I can turn it off, and then if I want to retract it, I can retract it. Now, this is how you got, so you need any way of programs that will manipulate and change these variables, will act on them so that we can make the movement and we make the sequence that we did over here. So for example, this variable here, I'm going to show you later on. This is the position of the cylinder variable. It's a real, you see here the type of the variable, you see it over here in this column. So this variable, for example, you may use it or you may not use it depending on the situation. But usually if you want to use it, it's a variable that changes from 0 to 1. So here, for example, if I want to move the cylinder 50%, so if I put a value of 0.5 over here, 0.6 here, for example, so it will put it at 60% position. Now, if I want to retract it, it's 0, I can retract it. And this is really depending on the type of program that you want to do with this system. But so let's do some sequencing over here and see how we can manipulate the 3D virtual system in Automation Studio. So the first sequence I want to do here for you, okay. Before doing the sequence, let me show you the examples. We're going to move the sequence later on. So let me show you what are the examples that we provide once you download the 3D system. So in the examples here, the demo files, you see, you go program data, FAMIC technology, 3D demo files. This is the templates. If I go to the demos here, so for example here, this is a PLC program. I can download, open in Automation Studio. So you see here what I used here. It's a normal ladder diagram where I can just, like if I do start my virtual system here, I can go in simulation mode, and then you see here the start button. As soon as I'm selecting the start button, so I'm actually doing here the sequence. The sequence here, this is the ladder program. And then once it executes, what you see over here, you see the sequence to make this system move. Now, if I want to stop it, so the stop, I'm not using in this sequence the start and the stop button. I'm using here button on from the drawing. So if I do a stop here, so it will stop the system here. Now you have another one. Let's do the other one here. I can show you another example. This is where you see how to do the system sequence using relay logic. So relay logic is another example that you. So you see, this is the program. This is a relay circuit. So here the same thing. I can start. Then I hit on the start button. Now I'm in simulation mode. I have the green is light, the red. The green light is here, and then I can start from my relay circuits, and then the relay logics here executes, and then I'm doing the same sequence but in relay logic. I'm going to stop it here, stop it. Then let's say stop here my sequence, and then simulation. Now you can see here the same stuff again, doing it using SFC. So this is the SFC, the graph set. Now, same thing, I have to launch again my 3D system and then go in simulation mode. Now in the graph set, I'm using here the, oh, I have to do is stop here. If I do a stop, it should stop now. Yeah, now if I do a start, so I'm using here the buttons for start and stop. Then what you see over here is the sequence executing in graph set. And then here is the 3D virtual system reacting upon it. Now let's start working now. I would like to do with you over here an example. I'm going to go to my template here. And the first example I want to do with you, I'm going to do a different sequence. I'm not going to go really rigorously to reproduce the same sequence. What I want to do here is this sequence. I'm going to do it here. I want to extend my cylinder, and then I want to push a disc, and then I'm going to do extend the B like that, and then, like retract my cylinder, and then retract my cylinder here. And so this is my sequence. Basically, push the cylinder A with a disc over here, and then once it's here, pushing it over there, but no drills. So just moving discs in the system. I want to show you how we're going to do this. And first of all, in Automation Studio that we'll do it ladder. We'll use in this example the Allen Bradley 5000 PLC library. It's a new library that is given in Automation Studio. And the reason why I'm using this library is because Allen Bradley 5000 PLC I can use directly the variables in the virtual system to act upon them immediately in a ladder, and not use the standard way of like the older style Allen Bradley PLC, where I'm using the B3 or N7 registers to do the programming in PLC. So I'm going to use the Allen Bradley 5000 PLC library to do this sequence. So as I showed in webinar 1, to start an Allen Bradley 5000 PLC program, what you need to do, you have to come over here and you open a new ladder diagram, and then the sheet, you're going to select Allen Bradley 5000. Okay, so before doing this, one extra detail, because I'm going to be using variables inside the project which is Automation Studio variables, what we need to do, and this is, we'll have to come over here, and in the properties of the project, here in the ladder, going in the ladder section, the automation section, ladder new, and then select Allen Bradley 5000, and then and this is strictly to work with variables here, Allen Bradley 5000. I have to select here, access to project variable. I have to check it to be able to manipulate directly the variables of Automation Studio. Once I do this, I can open my document here, my ladder. I can create it. Now it's created. And then we come over here, and then we can start right away doing the ladder programming. So I'm going to bring my power rail, and then the power rail, I'm going to just increment it like this, give it like that. Then I will going to zoom a little bit. Excuse me, I have my mouse is a bit sluggish. So here, what we're going to do, we're going to use the start button. So as using the start button, which is use start push button. So what I'm going to do here, first thing, I'm going to bring an instruction here, and then say the variable to come over here, we're gonna select from Automation Studio. So all the variable, if I do a filter here, let me extend a little bit the window here. So U underscore let me see here what it is. I should, why my filter is not working here. This, let me see, because here I don't see it because it, oh, sorry, project variables, it's ticked over here. Let me see, so here, if I use U, okay, maybe it, okay, let me start it over again, loading my template. Probably it's something related to my template here. So I'm gonna load my template here. Oh, I think I know what's the problem. Okay, excuse me. My problem is that to create the variable, sorry, this is, I missed this step because I have to load first my program, my system here, and then I have to go to simulation mode. So once I'm in simulation mode and I stop it, now I'm gonna have here the variables. Now the variable are created because the variable are not created if I don't go in simulation mode. This is because the first step, once I communicate with my 3D model create the variable that Automation Studio can use in simulation mode, okay? Now after that, I have to come over to the properties of my project here and then access the project variables. Here I checked it. Now the next step here is to come and create my ladder diagram. So here is my ladder diagram. And then I selected Allen Bradley 5000. So I'm gonna bring my power rail. And then here, let me extend it a little bit here. Okay, I'm gonna zoom a little bit here. And let's start. I'm gonna use here, first rung here. And I'm gonna say that it's the start button. So you see here, immediately if I put the filter, because the variable before was not there, was not created because I did not go in simulation mode. So the variable are there, so I can go here and start using my variables. So the start button here, I'm gonna say start. And then start. Once I'm starting, what I'm gonna do, I'm gonna turn on the light. So it's gonna be, I'm gonna say, I have a variable here. You can open this one, this window here. So the machine started. I'm gonna turn on the light. Machine started. So I'm gonna do here, machine started. If I do M, so machine started. So once I'm getting machine started, what you'll see here, that to get a better, I can enlarge a little bit the width of my instruction. So I'm going to make it like 3 in the component width. So here I can have it, instead of being spread on 2 lines, I can have it on 1 line. So this is machine started. Now, next part, I'm gonna just like put here a holding contact for machine started. So machine started, and you see over here, I'll go in the data section and just enlarge it a little bit. So here it is. So let's say, so now it's machine started. And then this is my first rung. So now once my machine started, now we can use some of the nice instructions. By the way, I can just, okay, here, machine started again, then use this one. I can use here in the program management, I'm gonna use an MCR instruction here. Now this is something like a routine, a condition that once my machine is started, this is a condition for everything executing between these two MCRs. It will be conditional on the machine started now. Next one, I'm going to put here an instruction. Let's work out now the ladder. Now what we say that at the beginning, if at the position my cylinder A, I have the contact here and I have the next condition is my block is in place, right? I can do an extend of this signal. So I can, of the cylinder A. So I'm going to do here. First one, I'm going to say if the cylinder, I can just filter, cylinder A is in the in position, right? And then my next condition here is the block is in place. So the block is in place is B, block in place here. What I'm, okay, block in place, you see here it comes in two lines, so I can just like make it 4 here, so it block in place. What I'm gonna do here, I'm gonna extend my cylinder. So here is gonna be UCYL. This is A extend is here. I select it. So A extend, and then I'm gonna have a holding contact for that. So I'm gonna use A extend here. So let's wait and see what's going to be the condition to turn it off. So to turn it off, basically what it is that we'll wait and see for now. So I'm going to have here my A extend. Now, what's going to happen that I'm going to extend the disc will move, and then the condition here to start moving the B is that I have to have my B in. When the B is in and the cylinder is ready to drill here, I can move my cylinder B. And also I can add to it the condition cylinder A in. By the way, in this condition over here, if you want to be very precise, we can add also the condition that B is in. So, and this way I can, like, when my A is in and B is in and I'm at this position, I can extend. So I can come over here and make it a little bit more accurate example and take the condition of my cylinder B is into. So I can take it like that. So this is really the condition to extending my cylinder A. Now extending cylinder B, so I'm going to say that If I'm reaching the end, let's say I'm going to say A out is totally A out. So I'm totally out, and I'm going to say that if the cylinder is ready to drill, so ready to drill signal is here, ready to drill signal, and then ready to drill, you see, to make it readable better. So I can just like increment here to 4. Now, once I have ready to drill, and also I have the condition here, the cylinder B is in, cylinder B is in, right? So I'm all the way out. I'm there and like this. Now I'm gonna push in this direction. So I'm gonna just create here the signal for B extend, and then I'm gonna hold it here with B extend. So, okay. So now I'm gonna move like that. Okay. Now I'm going to go all the way. Now, when I go all the way, I'm going to start retracting my A cylinder and also, retracting A cylinder and retracting the B cylinder. So my condition to retract here is if I'm all the way out. So when all B out is all the way, I can, and then I can say now even I can take the condition also that A is out. A is out. I can, let's say, at this point here, do my cylinder A retract. And I'm going to hold the signal here of A retract. Right? And then I'm going to say that the B retract also is when I'm going to be all the way out. Cylinder B is out. I can retract my B. And here I'm going to hold the contact. B retract. Now let us think about here when I'm going to cut the signal over here. So this signal, I can say that when I'm going to be totally out, when this signal is going to be out, I can cut the signal here. So for example, here, this signal, I'm going to put instruction here to say that here when I'm going to be all the way out. So this one, A out, will kill this signal. Now the B extend, also I can use the B out signal to kill this signal. Now the retract and the retraction, I can just say it's going to be safely. I can say when it's the B is in, the A is in, sorry. And this one is going to be the B is in. Excuse me, I did hear a mistake here. I see it, I selected C retract. It's not C retract, it's B retract. So this one we have to correct it to B retract. Here. And then all this condition, we have to, all this will execute inside the MCR. So the MCR here. So this sequence will execute only when the machine is started. And to execute only when the machine is started, this is an elegant way of doing the programming instead of adding this instruction over across the board here. I can just add it at the beginning and put it in MCR, and everything here is executing conditional to the machine started. Now what we can do here, let's test first this, and then we'll worry about stopping later by adding more programming to that. So I can just here start testing my logic. So testing the logic, what I'll do here, I can just like go in simulation. So once I'm in simulation, I can just like run. So you see here, I have my A. Okay, now here I'm having an issue. I want to extend. So ready to drill. Sorry. B is not, I don't have the signal, the B is in, I don't know why. So let me see here. I'm gonna stop this. Maybe it's something related to the variables. Let me start it again. Okay, now let's start it here. Oops. Yeah, I think my problem is this cylinder is coming in its way. Don't know why. Or I'm killing this. Okay, wait a second here. B extend. Oh, I think, yeah. You see here, I have a typo here. My holding contact is not B extend. I have here C extend. So I did here a mistake, so I have to correct it. And you see here right away that here my holding contact should be B extend. So I double click on it here. My mouse is really sluggish. Here, C extend. So it's B extend, sorry. Excuse me, am I having an issue with my mouse? Here, B extend. Now let's start it again. So I'm gonna start again. So you see here. Yeah, you see, my system here is like having one extra, and this situation may happen. So what I'll do, I'll stop it here and then come back again. And then here it is. I can just like start it. So you see my sequence is working fine. Now what I have to do is to do the stop part. The stop part, I'm going to show you, it's going to be very easy now to complete. So I'm going to stop this simulation. So what I'm going to do here, let me get back to my ladder here. So stopping, I'm going to come over here and then come and then say, I'm going to say here, the stop button. If I want to see the symbol of the stop button, I can open this window here to remember the syntax. So see, the stop button is U_S, is this button. So I can just come over here and then put S to do a filter. So here is my stop button. So if I'm hitting on the stop button, I'm gonna have something I'm going to call a stop request. So stop request, I did not create, I have to create a variable. So here I'm going to create a variable. I'm going to call stop request. So the stop request, and I'm going to show you why it's a stop request here. So stop request, and then I'm going to create holding contact for stop request. So if I put here S, stop request is here. Now the stop request, I'm going to say that if I have a stop request, and let's say the condition when I want to stop. I want to stop when the cylinder is at this position, cylinder A is retracted and B is retracted. So I have to have these two conditions to stop. So I raise my stop request, and then I'm going to say that if I am at the condition of the cylinder B is in and A is in, okay, now I'm going to stop machine. I'm going to create a variable here called stop machine. Okay. What stop machine will do? Stop machine will kill the machine started. So I'm going to say here stop machine. So this one will kill this signal. So as soon as I'm killing the signal, guess what's going to happen? I'm going to lose this signal. So this instruction not going to be true. So all this section will not execute. And I'm going to also kill the stop request that I created. So I stop machine. So stop machine will come over here and then we'll kill the stop request. And that's it. So this is for my sequence. Let's start it now and see what's going to happen. So I'm going to just complete this one over there. Now, if I come over here and then put it in run situation, now I'm going to start. So you see here, I'm going to do another cycle. And then here I'm going to stop. So this is a stop request. Now, once I did the stop request, I issued it, just like it waited for this 2-cylinder to come over here, and it stopped my sequence. Do it one more time. So just to show it over here. So you see machine started. Now, if I issue my stop request, see stop request is there. When the signal here, there, this comes in one scan, stop the machine, and everything stops. So that's basically it. So you see, like I could have made more, made it more elaborate, or let's say I can just started the drill and then moving and incrementing this sequence to do whichever things I want using the ladder. But this example is show you with ladder what you can do. You can do the same thing in graph set, and the same principle. I'm using directly the variable that belongs to my 3D virtual system. Now, another application of using a virtual system is to relate this system with real component in Automation Studio. And we're going to start something new over here. I'm going to show you what I mean there in the next example. So the next example, I'm going to, let's say, stop this. I can just save this one. Let me save it. Project, save project as. Here I'm going to put it into my desktop. My mouse is very sluggish. Here, I'm going to give it an example here. I'm going to call this is AS Drilling Factory. And then this is my example 5, AB 5000. And then say this is example 1. Let me load back again the template. I'm going to load the template. So I'm going to get, okay, I have my template here. By the way, it's a good thing for you to move the template in a safe way, instead of using it at wherever it's copied, to make a copy of the file before using the template, so that in case you mess up with the template or you do something and you save, you do not affect the original file. So let's work out now. So I'm having here my template. So as I said that before, the templates, if I open my template at the beginning, because I did not open the program, there is no file, there is no variables. So created. So to create the variables for the virtual system, what we need to do, I said we have to start it, to load it first, and to put it into simulation mode. Simulation mode variable, and then once I'm there, I can stop it. And then here, even if I close this file here, you'll see that the variable has been added to Automation Studio. This is the variable of the 3D virtual system drilling factory. Okay. Now let's see what we're going to do. What we're going to do over here We want to build the system in Automation Studio using components to simulate the drilling machine. And why we do that? Sometimes we do that just to build, for example, a 3D virtual system where we want to do, for example, troubleshooting exercises, for example, is one of the. So, for example, what I'm going to do, I know that I have cylinder A and cylinder B, so I'm going to build a pneumatic system. So I'm going to build here cylinder A. And then after this, what we're going to do, cylinder, I need directional valve. I'm going to use this. This is a directional valve, 5-3 directional valve. This directional valve, I need, I will modify it a little bit so that here, I'm going to add 2 springs here. And a spring here. Now I have the system here. Now what I'm going to do, and then after this, I'm going to put air, and then my exhaust. So for example, this is my cylinder A, and then I can just duplicate this entire thing. This is my cylinder B. Okay. Now, if I bring back again here my 3D system here. So let's see a little bit. Let me bring. So in a system like this, let's say I want to do a PLC program. For that, what I'm going to add here, I'm going to build a PLC. So with Automation Studio, we have the new PLC library. So I can just open the library. You open it by clicking on the Open Library button here, and then I'll do it again slowly. So open library, and then you're gonna, by the way, the PLC library, you have to download it from the forum. It's not available readily installable with Automation Studio, but you can download it from the forum. So the PLC library, you load it, and then once it got loaded, you install it, you copy the file in program data, FAMIC technology, Automation Studio E70 library, and copy the library. Then you can open it from there. And then when it opens, it gives you PLCs. So we're going to illustrate PLCs. So we're going to add here, let's say, one PLC to do the controls. So we're going to add this PLC here. Now, once we added the PLC, we'll need to add the devices that will go with it in relation to this system. So what do we have? So first of all, this signal here, this button will have to these buttons. Here's the start and the stop button and auxiliary contact for each one of them. So we're gonna come using the electrical library. Where is it? It's here, the GIC library here. And then we got the contact, and then in the contact, this is the start button. So the start button, to relate this contact to the start button in the 3D virtual system, we'll connect the variable of, here you see, if I put here the start push button, this is the start push button coming from the virtual library. We're gonna relate it to this physical electrical component. So I'll just double click on it. Now it will be activated by the system. Just to show you, if I go here in simulation mode, you see here what's going to happen as soon as I'm hitting the start button. You see this one is activated. So this is the electrical component relating to the 3D visual virtual system. So let's continue with the I/O. So I'm going to stop here. I'm going to need another one for the stop, right? So I'm going to come over here. This is the stop. In my system here, to do this animation, the one I said, the moving A and B cylinder, I need one over here, the blocking place, and I need the ready to drill. This I can use contacts. That's assuming that they're activated by a relay. There is a relay internal, so we can add a contact for each one of them. So I can add one contact for each one. So I'm going to have here this contact here. And then this one is relating, let's say, this first one blocking place. So if I want to relate this to the blocking place, so I just get the blocking place. So this one is blocking place. Now this one is going to be the ready to drill signal. It's a relay creating this signal. So I'm going to say the ready to drill is here. So I'm having the ready to drill. Now I'm also needing some signals for the proximity switches. I'm having here the B in and the B out and A in and A out. These are proximity sensors. So I'm gonna need here, I'm gonna go in the sensor switches and select one for each. So I'm gonna select this one is gonna be, let's say I'm gonna say this is a cylinder. I have cylinder A in. I'm having another sensor here and it's going to be cylinder A out. And then I'm going to have the B in. And I'm going to have here the B out. Okay. So this is the part that relates to my inputs. Now, for the outputs, I need an extend and a retract signal. The extend and the retract signal are to activate these two solenoid valve. So the solenoid valve here, I'm going to need in the output component, let's say coils, electric motor output component. Yeah, I'm having here two solenoid valve. I'm going to have this one is cylinder A extend. Let me copy this. And then I'm going to have same cylinder A retract. And then I'm going to have the same thing here. One is for or V, and then I got here the B extend. And then I'm going to put here my V retract. So this is my output signal that I need. Now what I need to do is, next thing is I need to relate this signal to the valve. So I'm going to just double click on my, so this one will make extending of the A cylinder. This is A cylinder, this is B cylinder. So this one going to be, if I go cylinder A extend, here, and this one here gonna be the cylinder the retract signal. Now if I come to the next valve here, I'm gonna have here, this one is the B retract, and this one gonna be the B extend. So you see here, I related the electrical component to the devices over here. Now, to make the motion here, these things will move. So I'm going to use the variable that are generated by this two cylinder. You see each one of these variable here is cylinder. If I go into the builder, it has a position sensor. So in the variable assignment, you'll see also the variable, each position sensor relates to a variable in the cylinder, which giving the output signal position. Now, remember what I showed over here, that the cylinder A and cylinder B, if I look at the model, the virtual system model, you see here, there is, when I'm hovering my mouse on the cylinder, there is a variable that shows, which is called U cylinder A and U cylinder B. And these two variables are the one that take care of moving this cylinder to give the position of this cylinder moving over here. So I can use this variable, and if I relate it to the output position variable of the cylinder over here, to make this cylinder move at the same pace, at the same speed as this cylinder when I'm going to go into the simulation mode of Automation Studio with the real devices. So the only thing I need to adjust over is to adjust that the ranges that this variable change matches the one that this variable change over here. So if I look over my model, I go into the start mode here, and then to see what's going on, if I go tools and variable, and then if I filter using U, so it gives me only the model of the 3D. So you see the variable cylinder A, it's a real, type real, and it changed from 0 to 1 to relate to the position of the cylinder when it, so if I change here 0.5, for example, 0.5, the variable, so the cylinder here moves by 50%. So here, 0, I bring it back again at the initial position. So changing the value of this variable from 0 to 1 will take care of giving the motion or the position of this cylinder while it's moving with relation with the variables of the coming out of this cylinder, pneumatic cylinder in Automation Studio. So let me do that, do this adjustment. So to do this adjustment, if you come to this cylinder here, as I said, the variable here is signal, output signal position is the one I'm going to use. It's real, but to know the range of variation of this variable, you to see it, if you go open here the builder and you click on the sensor here, you'll see that the value that the sensor give is 0 to 10. So here to matches the 3D model, we'll change it to 0 to 1. So we'll do it here, and then we'll do it here too, save changes. So if I do it for this cylinder, select the position, and 0 to 1. Now what we do here, after that, is we come over to the variable assignment and then take the output signal position. And if I use here U, this one is cylinder A, so I tie the two variables together. Oh, excuse me, this is cylinder B because I'm cylinder B, clicked on cylinder B. So this one, let me take off the assignment here. This one is cylinder B. Here. If I go there, gonna be cylinder A. Now, what we did over here, everything over in Automation Studio, like these devices are really tied up hand in hand with the 3D model. So if I continue doing my exercise over here, to continue my exercise here, and then do the buildup of the circuit in Automation Studio, if I'm going to go in simulation mode, while Automation Studio do my simulation of my devices over here, the model also will be working with him hand in hand. So it's going to be, it's good. So this model will be the visual representation of this symbolic way of representing the system, this pneumatic cylinder, pneumatic system, and electrical system. So let me continue. I'm going to just do this part very fast, do the wiring on the PLC here. So I'm going to show the basics part, but I'm going to show you the final in an example. So so here I'm gonna to make this wiring nice. So I'm gonna just rotate. So here it's rotated. I rotated my PLC just to adjust to this symbol over here. So I'm gonna just like adjust here my text. On each one of these, and then let me view my grid so I can just like see it better. So let's say I'm gonna do my work here. So I'm gonna, let's say, use this spacing, try to be here. So this is my wiring here. Now let me do this cylinder A. So you see over here, if I do the wiring, if I bring the output 5 and output 4 on the PLC, so I'm gonna just move the text here. Then this is going to be my solenoid here. Okay. Now also I forgot to include the light for the machine started. So machine started, I'm going to go in the output component. I'm going to use signaling device. I'm going to use here this one. And this one, I'm going to say that this is the U machine started signal. And here, if I double click on it, and then I have to relate it to the model. So I'm going to use the U machine started here. So if I double click, now the lights, when it's going to be activated physically by the PLC program, it will turn on the light in the 3D model. So now let's continue here. So I'm going to come over to my power sources, continue with the wiring. So this PLC need L1 and the neutral. So here, this is, I'm doing the wiring, neutral. Now, what we're going to do, we're going to power these relays. So I need to come, and this is the, here, and then this one too, and this one too. These outputs, and then after this, I have my outputs. And then once I power this PLC, I'm going to get 24 volt out of there. So I can use here the 24 volt to send the signal to my inputs. Okay, let me do it here. Let me take this one here a little bit. Here. Here, and probably I'm needing some space here. So what we're gonna do, we gotta, yeah. And maybe it takes. And then, oh, this is a common here. It's gonna be coming there and coming there. Now this line, I'm gonna bring it. Can come like this. Now, this goes for the return and come from here. So basically that's it. So I'm having now, this is my PLC wiring. This is my circuit here. Now the next part is if you want to do this, we're going to do, let's say, I'm going to do it now. Instead of doing with Allen Bradley 5000 library, I'm going to do it with Allen Bradley 500 library. And then, so I'm going to come over here, and then you can add the Allen Bradley 500 PLC library. You can use this one. So to use this one, basically what it is, it's just like we'll have to add the ladder diagram here, 500 ladder diagram. So if I use it now, next part, since we are doing the preparation, like I showed you in the first webinar is recorded, you can refer to it. Not going to go through the details here. So, but basically what you do, you open here the ladder sheet, and then you select the PLC configurator, go on ladder 500 and input output, and let's create my interface. So the only thing I need to do here is to, before doing this, let's see what are the addresses I'm using. So if I go, let me see here. You see, I'm having here, let me Project Explorer. Let me show my ladder here. I'm going to put it in the view. So if I come here, I'm going to zoom up a little bit. So you see, I'm using in the outputs from 1 to 5, and from the inputs, I'm using from 2 to 9. So what I'll need to do, I go on the ladder sheet, and then ladder, and I'll add my inputs. So here I'm going to start with my, let's say, my inputs. And then I'm having from 2 to 9. So I can just like double click 8. This is actually my mouse, that is 9, 8. Okay, I'm going to add my inputs. I'm going to add my outputs. And then the output's going to be from, like I said, from 1 to 5. So 1 to 5, 4, 5. And let's say I added 8 and 9. By the way, like I didn't add the other just because I'm trying to show you the steps. But then after this, we add the addresses here and the aliases. Let me put you through the examples, the one that I already did, because I did this example for you. Cancel here. Please see here. No, save this one. I'm gonna save it here as example 1. So working this exercise, like I showed you here, this is the final. The final, what it is here is that I did my programming. This section here is, if I follow up with it, you see here, this is how I added my input and my output. And then after this, I selected the areas in the PLC that I want to map to this input. So I selected the B3 area. So I'm selected also in the B3 area. I took 0, a range of B3 0 register, and I took the bits in the B3 0 to represent my outputs, and the B3 1 to represent my inputs, and then I created here the register alias for each one of them, for each one of these addresses. And then once I created this section here, it's very simple after that to go here and start the programming. And the programming ladder that I used over here is the same logic I used in the other one with Allen Bradley 5000. Same logic, same sequence. Then after this is the part where I have my circuits. This is the one I built with you. Now I added this area, this point over here, just to refine a little bit in controlling the speed on the cylinder, by restricting the airflow. By the way, I'm not a pneumatic expert, so I think this should do it to control the flow. You can refine on that because you know better the subject in pneumatics than me. But based on that here, I can go in the link. Let's start here the sequence. So I loaded my system here, and then if I start, yeah. Now, things that need refinement over here, and this is the whole purpose of this exercise, is that the speed where this cylinder is coming, I have to, because it's going a little bit fast, it's not moving this cylinder smoothly because it's going faster, because in the 3D model of Automation Studio, we are using Unity gaming platform. So all the physics that relates to the component over here, they are related to each other. So the friction effect of this cylinder with the trough over here and the motion of this moving arm, to synchronize it is we need to do it a little bit slower, because in a real system, if the cylinder goes very fast, you're probably gonna have some issues with the cylinder, like the disc moving over here. So to really improve on that, you have to improve on the design of the pneumatic system. What we need to do is we need to move here a little bit slower, adjust the flow rates by doing adjustment over here to make these things maybe go a little bit smoother. So let's say if I'm reducing my diameter to 0.1, for example, to do it slower. Maybe I don't know if the cracking pressure is properly too. Like I have to adjust also the cracking pressure. I can just like and then let's start. Okay, start here. So you see here, I'm probably moving slower. So here I'm more in control, but you see, I can refine more into the design of the system here by doing the adjustment in the parameter here to do my sequence. But you see, over the whole purpose of all this exercise is I can simulate this to a real system, and it's not basically now an animation problem. It's a physical problem where, you know, like it relates to real components and simulations. So you see over here, this one, because it goes so fast, it went. I have to refine also on this section. Let me do here. And change an adjustment over here to, let's say, 0.2, for example. So you see here the physics of Unity in the 3D model makes the system react as if it is a real system. You see now, because I'm going slower, and so on. So basically that's it for my presentation of today. I don't know if you have any questions. So you can raise your questions, or I'm going to open the microphones now. So for you guys who wants to raise any questions, you can raise them, and I'm giving you the microphone to raise them so everybody listen to you in the room. Is there any question? Yes, Doug, I'm going to give you the mic. Yeah, the mic is yours now. Yeah, the mic is open. You can speak now. Your question, Doug.
Can you hear me?
Yes, I can hear you.
Okay, how did you create that automation studio itself? How did you draw it up? And how did you create that?
You're talking about what? About the model
factory here? Yeah, how did you create that?
Yeah, this model is created with Unity software. It's a platform. It's a 3D platform using for gaming. So, you know, like you can build your 3D model using this platform, 3D, and after that, we can add to it we have some sorts of way of configuring it later on so that it can communicate with Automation Studio to exchange variables between Unity and Automation Studio to do these animations.
So are you going to be creating a library of these factory?
Exactly, and this is basically what we are trying to show you over here. We already created a whole bunch of these 3D models, and then you can download them from our forum. And by using the variable that I showed you, well, each one of this model, I can show you the others. I can show you other examples where we can, like with the other model, just acting upon the variables of the model, you can do this sequence and simulation.
Okay, thank you.
Okay. There is Michael. Okay.
George?
Yes.
If I may ask, if I may add something, maybe to answer Doug and also Mike's question that we received. We have a module that is sold separately to Automation Studio. It's called Unity, let's say, connectivity, I would say. And any system designed in Unity 3D can actually be connected to Automation Studio, but you need to use this this module, which is sold separately, that will describe to you how to make that link possible. So we have pre-created 15 systems like that, which, by the way, they are not on the forum right now. They will be on the forum, let's say, maybe Thursday this week or Friday at the latest, because we're kind of like compiling them and making sure everything works fine before we upload them. So they'll be ready soon. But if you do want to create your own, we have a package for that. You can talk with your representative and he will be able to provide you with additional information. Thanks, George.
Okay, no problem. Okay, is there other question? There is Michael Seafard. I think he raised the question. I don't know if you want to take the microphone. If you want to take the microphone and speak out something, Michael, just raise your hand. I'm going to give the microphone and then speak up your question. Is it okay with you? Okay, I think it's okay with you now. Okay, no problem. So, yeah, is there any other question, gentlemen? You know, by the way, you know, like you see over here, and I'm just trying to show you. I want to bring up to the front. You see here the model. I want to show the model running over here. This is sequence running in real components in Automation Studio. And then you see here the how it's reflected over here with the 3D model. Okay, there is Amir Hossein. Okay, yes, the microphone is yours. Let me get it. Let me give you the microphone. Excuse me, I'm just trying to turn on the mic for you. Can you unmute yourself? Yeah, okay. Amir,
Hello?
yes, Amir, it's yours.
Nice job, sir.
Okay, thank you
I
very
have a
much.
question.
Right, go ahead.
Can we connect the Automation Studio to the other software like Fluid Sim for simulation, for example, in the hydraulics or electrohydraulics sections?
Depending, you know, like if Fluid Sim, yes, we can connect to other software using OPC, depending on if Fluid Sim supports OPC. So if it supports OPC, yes, and then we can communicate with other software. And we also, we have another module called co-simulation where we communicate with LabVIEW in co-simulation. So yes, it's possible. But
Well,
depending,
thank
you know,
you.
like what, but depend actually in your software multisim, what kind of application is this? Is this pneumatic simulation or electrical, or multisim is what? Is for electrical system?
Yes.
Okay. Yeah, we can communicate. If multisim communicate by OPC, we can communicate with them and integrate them together. Absolutely.
Okay. May I have another question, sir?
Yes, sir.
Okay. Can we see inside the cylinder, for example, the animations during the simulation?
What do you mean? You mean cross sections or something like that? What do you mean? You see inside?
Fluid mechanical, I mean. For example,
Pardon?
when a cylinder A turning to output A plus, we can see the inside the cylinder like a fluid. I see that in the version 5, Automation Studio Professional version 5. Can we have this?
Talking that?
Oh, yes.
This is what you mean?
Yes, but it simulate just for one actuators. Can we set for the two actuators simultaneously?
Yeah, we can replace this here. If I would have drawn this using, we have a library. Let me see if I can, I have it over here. We have a cross-sectional library.
Okay.
See here, where is sectional hydraulic component? Yeah, sectional hydraulic component. Let's say
Hi,
if
George. If you want, you can open a template called cross-section view that already has a circuit drawn.
For example, here is like miscellaneous here, tank, hydraulic pumps, flow control. Yeah, for example, where is the cylinder there? Yeah, for
Okay.
example, like I can bring over here if I can bring a pump, you know, like it's his cross section, and then I have then, for example, I can just bring, but this is hydraulic components. We should. I know that we have one. Christian,
Yes, George?
can you? Do we have it for a pneumatic?
Yeah, if you can just do George, go to the home and just do a new project. And there's a new project called Fluid Power Cross Section View.
Okay, let me see. I'm gonna just create now. I'm gonna create a new project here.
And choose a template called. Hold on.
Let me see here. Let me see here. Okay. Save changes. No. So
Okay, then
yeah.
choose the. Hold on, I don't see you moved it. Choose the. Okay, go down, go down. There. Okay, go back up. It's going to be called. Go back up. Yeah, this one, cross section. You're right. You're right. You're right. This one. It already has a circuit done, but you can obviously add more to this circuit, and everything actually works together. So you design your own circuit with cross-section view. If you
Okay.
simulate, you will see the flow actually been driven through these, and then you can add as many cylinders as you want on that drawing.
So for example, you can just like.
Thank you so much, sir.
And launch a
Yeah.
simulation, you'll see.
Okay.
Nice job.
Let me run the simulation here. So here.
And you can move, yeah. Move it more.
Well done.
You can move it more. That's it, yep.
And the simulation connected to your PLC program, they are simultaneously work together?
Yeah, absolutely.
Okay.
Yeah, it's not
Very nice.
not in this specific model, but we can just tie this circuit to be directly connected to a PLC program. And the PLC, like you saw the library, you know, like we have a library of PLCs, different PLCs. For example, here, this is the library over here. We can just bring the PLC to the drawing, and then we can connect with electrical component here, then tie everything together, and then from there we can let me try to show an example.
Thank you.
For example, here, yeah. Let me see here on the examples we have in virtual systems. I'm going to go to, let me go to the C, program data, FAMIC technology, 3D demo files, the demos. Let's see here what we have over here, the drilling factory, really. Yeah, for example, here. By the way, you know, like this is the PLC program,
Yes.
that relates, but you know, like I didn't add the integration with the components, but I can add the component, integrate the component, and then have everything relate tied in together. So let's see over here if we turn it on and start it. So we have here, this is the pick and place system. But what I could have done over here, this is what you see as a machine, but I could have created over here the A, B, C, D cylinder, the pneumatic cylinder, and all the devices that control them, you know, like the sensors and stuff like this, and do the real circuit running and relate it to the virtual system over here to show, you know, like how they interact together, like I showed you in the other example. So you can fine tune in like changing the speed on the cylinder by changing the airflow, and you may in Automation Studio generate errors or faults in the system, and do troubleshooting exercise and see, you know, like when in a 3D model how it's going to react visually. So you can put more than one library. All the libraries that in Automation Studio are related together. So whichever thing you see over here in this panel, which is the Library Explorer, it shows you all the technology that could tie in together into the same project. So in your example here, where we shown, you know, like these are a library for sectional views and stuff like this, we can add it and add to it any one of this library and tie all of them together. So you see, you can add hydraulic, proportional hydraulic, pneumatic, proportional pneumatic. We got drive and transmission element, environmental control, PID, set point devices, whole bunch, electrical controls. We got different standard, GIC, IEC standard, digital electronics, ladder logics, electrotechnical, IEC and NEMA, block diagram, and we can put all the stuff together. Also, even you can add HMI components here, basically see buttons and make an entire project and everything connect to each other, and then you can see how everything relates to each other live in the same environment, under the same platform. That's what makes the software, you know, like unique by itself. It's because you can have more than one technology simulated in the same time.
Thank you very much, sir.
No problem.
Thank you from Farming Technology for this useful software Automation Studio. Go ahead and good luck.
Okay, no problem. Okay. So is there anybody else who has a question? Doug, are you okay? Okay. While I'm giving you the mic, if you're self-muted, so you can unmute yourself. While, are you there? Okay. I think Weil already raised his question in the panel. Oh, Weil, if you want to speak on the microphone. Okay, no problem, Weil. Thank you very much for your presence. Okay, so that's it for today, everybody. Oh, I can talk. Oh, Doug, you are self-muted. Just like unmute yourself, Doug. You'll be able to talk if you wish to talk. You have to unmute yourself. Okay, Adriana.
Okay, I can get in now. Thank you.
Yeah, okay.
Okay, I noticed that you'd have that 3D view of Automation Studio window.
Right.
Can you resize it?
Okay, let me see. I'm gonna turn it on. Let me start a new project here. No, let me start a new project again. I'm gonna go here. Restart a new project, and then let me take again the.
Joy, I think he was talking about the 3D virtual system window, if it can be shrinked.
Yes, that's right.
Oh, you're talking about the 3D? Yeah, you can.
Yeah, if you can shrink it, and if you can show the people how you can also put the split screen between OIS and the 3D view, that could be good, you know, to program.
Okay, let me
Yeah, that's good.
Let me open a project here. So I'm gonna say, let's say the pick and place, for example. Okay, Adriana, we'll give you the mic as soon as we finish with Doug. Just stay there. We'll give you the microphone temporarily. So if you go over here, I can just like put it in split screen here, and then yeah, and here like I have to switch camera probably to make it easier on the eye. So here, for example, and then let's say if I want to start, it started, and then I can run it from here.
Can you also reduce it even more just to show that we can do it the size we want? It doesn't matter.
Okay. Yeah, that's good. Yeah, because you're moving it around, so I wasn't sure if that was restricted or not. Okay, good. Thanks.
No, you can really size it, shrink it, and
Okay, good. Thanks.
okay. Now I'm gonna give the microphone to Adriana. Adriana, you are self-muted. If you want to speak, you have to unmute yourself. Do it again. I think try to unmute yourself. Well, I don't know. Well, I don't know, Adriana, if you want to speak, you have to unmute yourself. Otherwise, you know, like I cannot do much from here. You know, like you tell me that you are self-muted. So
Yeah.
okay, okay, yeah. Now you're okay. Now you can speak. Yes.
Right. Thanks. So I see that the 3D simulation that it will be included in the Automation Studio 7 will
Yes.
only be like models of pneumatic and hydraulic, or they may include the variable frequency drive.
Yeah, sure. Absolutely. You know, like whichever things we build in Automation Studio, we can tie it in to the 3D simulation parts with no problem. Yeah, of course, we can do that.
But in the Automation Studio 7, the models that you will be including will be like only pneumatic and hydraulic, like the one you're showing us, or
Yeah, the one that, for example, the model that we are having over here is like it's basically the showed hydraulic and pneumatic systems, but you know, like there is nothing preventing us, if you have something in mind, that we can build a 3D system that needs to be activated, for example, with variable speed drive. For example, in the example of the drill that I showed you, the only part which is electrical is the drill itself. For example, let me load it. Let me load it and then show you what I mean here. So if I open the model here, if I open my, let me get here my full screen again. having something that is no, okay, no, okay, here. So let's say if I'm going to, let's go with the PLC here. Okay, now if I open my 3D model here, you know, here in the simulation, I can here, I run it. Now, for example, in exercise like this, the electrical part that takes care of the drill by itself, which is like the motor that turn on the drill, we can build over here an electrical circuit where we can activate this drive, this drill, with either a variable speed drive or a soft start. And then we can add it to the model and add it on top of, you know, like the pneumatic system that we have over here. I didn't put it there because I wanted to be as much simple for you guys to grasp the concept, but I didn't want to complicate it much, you know, by adding more on it. But by all means, yes, you can do it. And I have this model where, you know, like you have the electrical part on top of it, but I don't have it really with me on this computer. But if you wish, I can send it to you, and then you can examine it, and you see that we can add in the one I have a soft start for the motor that activate this drill, but we can replace it with a variable speed drive for it. No problem.
Right.
Yeah.
And
works.
for example, if we want to add like a power flex or something in the 3D simulation, will that be available?
Yeah, the power flex is available. It's part of yeah. We have the power flex in the electrical catalog. Yes, we can add it. If you wish, we can just like we can meet again, and then we can discuss these things. I can show it to you over in details in a separate webinar, or yeah, if this I probably have your email, or you can have my email. It's jfatal@famictech.com. Just communicate with me or talk to me, call me, and then we'll organize another webinar together where I can just show you the electricals, how we can add the electrical parts to the 3D model. Do you want to do that?
Yeah, that would be really perfect.
Excellent. So, okay, so I'm taking note, Adrian. I'm going to be in touch with you. I'll have your coordinates. If you send, you have the email.
Yeah.
And then we're gonna organize something together.
That would be really nice. Thank you very much.
No problem. Okay. Is there other question? Well, okay. So I think that's it for today. Welcome again, and thank you very much for your time. And then we'll see you on Tuesday next week for the last webinar in the series, where it discusses about securities, how to protect document and protect project and use them with your students and share them with your students. Okay, so thank you everybody. We'll see you next week.